Hi guys, I hope you had a good weekend. Today you're going to have two videos to watch. The first one's going to be on the period shift, and then the second one will be on the horizontal shift. So that way on Tuesday we can do some mixed practice in the Zoom session together. Okay, so this file on the period shift, I'm going to actually start with two problems where I kind of recap from Friday. I felt like the end of Friday's video was a little rushed. So in this problem right here, -2 plus 5 sine x. This -2 is our vertical shift, and it's moving us down 2. Okay? The amplitude is the value right in front of the trig function, so that would be a 5. Whether it's a 5 or a -5, the amplitude is always just a positive number. So far, you haven't learned anything that's going to change your period, so our period's 2 pi. Later in this video, we'll learn how the period will change. Okay, and then your quarters, you take whatever your period is divided by 4. So if I take 2 pi over 4, that's simply pi over 2. So far, we always start at 0, and then we count by our quarters. So we add pi over 2 on, you add pi over 2 onto that, you get pi, add another pi over 2, you get 3 pi, add another pi over 2, you get 2 pi. Now, the values for sine, I had mentioned last week, some kids like the little acronym of YOLO. So 0, 1, 0, -1, 0. Okay? Now, that represents the value of just the trig function right here. So sine is 0, take that times 5, so still 0, and then -2. Okay? 1 is the value of just this portion right here. So 1 times 5 is 5. With that -2 would be 3. Any of the zeros are all just going to be -2. And then -1. So if this is -1 times 5, so -5, and then -2 would be -7. Okay, so if we want to plot this, oops, okay, the lowest value that I have is -7. So that's my lowest y value. So let's go ahead and do the range. So -7, and the biggest y value I have is 3. And those include those values. So -7. Okay, so this is the order pair 0, -2. Pi over 2, we're up at 3. Pi, we're back at -2. 3 pi over 2, we're at -7. And then back at -2, and connect those with a smooth sine curve like so. Our domain for these are always going to be -infinity to infinity. They technically go on and on forever in that oscillating fashion. We're just showing one period of that graph. Now, the amplitude I had said was always the value from the center to the peak. So here, our center line is here. So from that center line to this peak, or from the center line down to this peak, should be 5. So this is at -2 because of the shift down 2, and then up to 3, that's 5, and this is 5. Okay, so the amplitude is from that center line to that peak. So here the whole center line, which is normally at 0, was shifted down 2 because of this guy, and then our amplitude is 5. Okay, let's look at one with cosine. So here my vertical shift is up 3. My amplitude is 5. Now, it doesn't matter about the negative. That will affect our values in our table and what our graph looks like, and I'll talk about that in a minute. Our period's 2 pi, and this is pi over 2. So these pretty much are the same as before. Okay, now cosine, the value is 1, 0, -1, 0, 1. Okay, so the trig function right here is 1. Take it times a -5, and then that's a positive 3. So we're going to have basically 3 minus 5, so -2, and that's the same value there. If I put in 0, this whole thing's 0, so these are just 3. And then if that's -1, this would turn to a positive 5 plus that 3, so 8. So my domain's -infinity to infinity. And my range, my lowest y value is -2, and my largest is 8. Now let's come over here, plot this. Okay, so 0, we're at -2. Pi over 2, we're at 3. Up at 8, 3, and then back at -2. And once again, it's kind of like a smooth curve like that. So what you notice here is your normal sine graph looks kind of like this, and your normal cosine graph looks kind of like this. So this took our center line of our normal cosine graph, and it moved it up 3 because of that vertical shift. It stretched it because of the amplitude of 5, and it reflected it because of that negative. See how it went from this to kind of upside down? Okay, so that's what that negative is going to do. It's going to reflect the graph. Okay, so that's kind of the basics with the vertical shift and the amplitude. Now let's dive into what the period shift does. So now there's a value inside the trig function right here, this b. This is important. The period, we had said before, was just 2 pi, but it's 2 pi divided by whatever the absolute value of that b is. This is important. Before, there wasn't anything in with that. X technically a 1, okay? But now we're going to have values inside. So just to add on, there's no vertical shift here, so you could do that, or you could just say none, right? The amplitude, there's no value out front, so technically the amplitude is just going to be 1. Now for our period, we're going to take 2 pi divided by 2, that value inside here. So my period's now just pi. My quarters, we had said before, we always take our period divided by 4, so this would be pi over 4. So now we start at 0, just like before. We haven't seen anything change with that quite yet, but we're counting by our quarters of pi over 4. So this would be pi over 4. If you add on pi over 4 to that, technically it's 2 pi over 4, which I'm going to reduce to pi over 2. Add on, that would be 3 pi over 4. Add on another pi over 4, that would be 4 pi over 4, which is just pi. Now the values for sine are the YOLO. Okay, so 0, 1, 0, negative 1, 0. So the trig function here, not a lot's going to change in this one because this is a basic example. So this portion right here is just 0, 1, and negative 1. So if there aren't any other transformations or manipulations here, this is just going to hold the standard values. And we'll kind of see what's going to happen here in a second. So now, when I break this up, okay, so I'm at 0, 1, 0, negative 1, 0. Now the normal, sorry, I missed that a little bit. The normal sine graph went to 2 pi. Okay, so I'm going to show you here in a second in Desmos what this did to our graph. Our domain is still negative infinity to infinity, and our range in this one is 1 to 1 because that's my high and low y value. So let's look real quick here. Okay, so this is your normal sine graph. Okay, it repeats itself at 2 pi. It starts to repeat itself. Now, watch here. If I put a 2 inside what we just did, see how it repeats itself faster. Okay, it took horizontally and it shrunk in our graph and it repeated faster. So if I put in 4x, it's going to repeat even faster. And 10x, it repeats even faster. So let me take those back out. Now, if I put in 1/2, notice it's stretching it out, and it doesn't repeat itself until we hit 4 pi. Whoa, 4 pi. Okay, so that kind of stretched it out. Similarly, if we do the same thing with cosine, there we go. Okay, cosine repeats itself at 2 pi. Oh my goodness, normally. Okay, if I put in a 2, it's going to do the same thing. It repeats itself quicker at pi. If I do the 1/2, it pulls itself out and repeats itself at 4 pi. Okay, so you can see how it's stretching with our stretching or shrinking our graph horizontally. Okay, let's look at another example. So here, now I have a lot of stuff going on. Okay, so my vertical shift is down 3. That's this piece right here. My amplitude is the value out front of that trig function, so it's 4. Now my period, I take 2 pi divided by whatever this b value is. So if I take 2 pi divided by 1/2, that's the same as multiplying by 2, multiplied by the reciprocal, so that would be 4 pi. Now my quarters are my period divided by 4, so this would be pi. Okay, so far we're still always starting at 0. We haven't messed with that. So now we're counting by a quarter of pi. So add on pi, pi, and pi. Now, since we said the period's 4 pi, this better be completing its one full cycle, and we better be ending at 4 pi here. We got some problems if we're not. Now, the values of sine, the YOLO. Okay, so now here, the 0 dictates just this portion right here. So if I take that times 4, still 0, and then negative 3. I'm going to fill that in for all the 0 spots. Okay, now 1. This portion comes out to 1 times 4, and then a minus 3. So that would come out to 1. If this portion's negative 1 times 4, and then a minus 3, so negative 7. domain's still negative infinity to infinity. As you saw in Desmos, these graphs go on and on forever. We're just graphing one cycle of it. My range, my lowest y value is -7, and my highest is 1. Okay, so let's go out to 4 pi. Okay. So at 0, we're at -3. Pi, we're at 1. 2 pi, -3. -7. And back at -3, connect that with a smooth curve. So that's what one cycle of this graph should look like. Okay. The normal sine graph, if you think about it, it did one cycle in 2 pi, and it was like basically, hold on, it was like this. Let me do that in a different color. So this graph's moved a lot. It moved its center line down 3 and stretched it vertically by the 4, and then it stretched it horizontally, or stretched it horizontally by that 1/2, kind of pulled it out this way as well. Okay? Let's do one more over here off to the side. So y equals 2 plus 3 cosine of 1/3 x. So my vertical shift is up 2. My amplitude is 3. My period, okay, so 2 pi divided by that b, which is 1/3, so technically multiply by the reciprocal, we would get 6 pi. Your quarters, 6 pi divided by 4, so I'm going to reduce that to 3 pi over 2. Okay? Now, these don't all always nicely add up. Sometimes they are, sometimes they don't. Okay, so I start at 0 and I count by 3 pi over 2. So if I add on another 3 pi over 2, I get 6 pi over 2, which is technically 3 pi. Add on another 3 pi over 2, which is 9 pi over 2. That doesn't reduce. Add on another 3 pi over 2, which is 12 pi over 2, which is 6 pi. And we said our period should be 6 pi. Values of cosine are 1, 0, -1, 0, 1. So if my trig function comes out to 1 times 3 and then plus 2, this should be 5, and then so should this one. If this is 0, this whole thing's 0, and I just get 2. If this is -1, we have -3 plus 2, so -1. So rough sketch graph here. Okay, oops, my domain is -infinity to infinity. My range, my lowest y value is -1, my highest is 5. Right, so it's 0, I'm at 5, then at 2, -1, 2, 5. Okay, now the 4 homework problems that go along with this are listed below. Now in the key, I don't have the full analysis. I really just have the table, domain, and range, and the graph, so you can see what that looks like. You should have the full-blown analysis like I just did in the notes here with all of the pieces listed for these 4. Okay, in the next video, I will talk about horizontal shifts.